Okay, so thank you all for joining. We will be talking in this live webinar about the DevOps fundamentals. We will try to touch the core principles of this methodologies, but in the same time keep a practical conversation and get some hands-on experience. First of all, I would like to thank Bunnyshell for organizing this and having us all together around this wonderful topic. And thank you all for joining as an audience and as a big community that is increasing around this topic. First of all, let me introduce myself. I'll try to be short. My name is Eduard Budacu. I will be your technical trainer for today's session. At core, I'm a web developer, so I have the PHP elephant here with me to keep us luck for the demos that we will be trying. I have around 12 to 13 years of experience in working with web development teams. In the past time, I've been working as an Agile coach and consultant for software development teams, dealing with better methodologies for organizing themselves and tools to become more productive. I also have a passion for teaching, and I teach web technologies at a local university here in Bucharest. And I try to be as much as possible an active contributor in local communities to share and learn about the latest advances in software development. So today's agenda, we will be discussing about DevOps principles and practices and put them in real life with the tool from Bunnyshell. The main concept will be around reliability, performance and scalability and maintainability, and see how these concepts get applied by teams and how you can level up your DevOps practices with the solutions provided by Bunnyshell. Before starting, I would also like to get a feeling of the audience now. So maybe please share in the chat, maybe your tech stack, what technologies are you working with, what kind of tools are you building, and where are you from, or maybe how is the weather around. I'm in Bucharest. It's pretty cloudy. Spring is coming, but it's pretty cloudy, not rain. So I see that we have such a diverse audience, and I would like to get a feel of it, even if we're not all in the same. Thank you, Carmen, for sharing.
We have to write it, or can...
Yeah, simply write it in the chat for everyone to get to know each other.
Okay, then.
Thank you. Great. Okay, let's deep dive into the conversation, a topic I really like and I really enjoyed talking about. So uh, I don't want to bore you with the history, but it's since it's a talk about fundamentals, I would like us as an audience to think about the core principles of the subject. So I would like to start with a little interaction, and maybe some of you can guess what this is. Maybe you have seen it in your university or in a computer museum.
Paper used in the past for programming uh, punch cards, or I don't know how is it called.
Exactly, punch card paper. So this kind of piece of paper was where you had to write code, and then someone actually had to take a big case of this, a case of these pieces of paper that were punched by programmers, take them to a dedicated compute center that had a huge mainframe, and actually carry a big box of this, and this is how they deployed their software, to take it there to the mainframe, put in all the cards, and this is how the creation of a programmer came to life, by actually moving things around buildings. So the core problem actually remains the same, but now we're working in a very distributed, and our pieces of code get shipped from our local computer to data centers all around the world in very few moments, but the core principle remains the same. We want to enable people that are creative and that have the ability to solve problems by writing them in code, to ship and to solve that problems to customer all around the globe in a matters of seconds. So what some what was a very long cycle of thinking, um, of punching holes in a card, taking the back box of cards into the data center, has radically transformed now with the rise of the internet. But the same principle remains the same. We need to have a way to ship these things that we are creating. With the advance of internet technologies, obviously the way we do deployment has changed. A few references about this DevOps concept. One of them in 2008, in a conference in Toronto. It was the first time where it was mentioned, the term Agile system administration, and people started debating about the problem of building software and also deploying software, and do it in a matter of collaborative way. So further references and some authors that I really enjoy reading, and I recommend a book called The Phoenix Project, written by Patrick Dubois, Jeanette Jim, and John Wills. It's a book that tells, as a novel, the struggles of an IT manager that is dealing with a legacy code base in an organization that is shifting towards a digital transformation, a traditional organization, and they put it very well in a story of that main character, Bill, that has this tremendous problem of bringing the development team with the operation team together to solve the problem. So we can see DevOps as a culture that aims to use technology to bring these teams together. And in their book, they described like some ways of seeing this problem. The first one would be having a team of developers and having a team of operation. And the development team is sending their code to the operation team to do the maintenance and to publish the code. The second way they are describing as part of the solution is creating feedback loops between two teams. So not only pass the code around, but also create a healthy habit of sending and receiving feedback and trying to improve the way they build software. And the third way is trying to obtain a continuous cycle of delivering where you work in small iterations and you try to deliver software in batches as continuous as possible and have this continuous loop of getting feedbacks from the team. So one way to see this DevOps movement is a cultural shift of bringing people together. Another way is to see the outcome that we try to achieve. We want to get as soon as possible in the market with our products while maintaining a high quality. So in this DevOps world, you will see a lot of references around being a lean company or an agile company and try to get your products as fast as possible to the customers to get feedback. But complex problems that are solved with software also require a higher degree of quality. So you need to find the right balance between this part. So this is another philosophy of looking at the outcome to gain speed and traction. At core, DevOps relies on having some characteristics in mind. And I always like to debate with myself whether these characteristics are regarding the software that we build, but in the same time, we can see them as characteristics of the teams that are actually delivering the software. So in the DevOps world, we always hear these terms like we need to have a reliable software, we need to be performant to allow it to scale, and obviously to be maintainable. So I suggest to take them one by one and discuss them and see a comparison between the software characteristic and the team characteristic. So reliability, in terms of software, we realize that systems are fundamentally not working, in a state of not working. So until a user goes onto the platform that you've built and starts to interact with it, this is the moment when the software actually starts working. So we need to figure out how the system will perform when its user interact with them and they expect to be available in all the conditions and be available in all periods of time. So in order to gain reliability, people need to trust your software and trust you as a team that you have the tools and the abilities to keep it working. So for this part in the DevOps area, we see all the monitoring metrics, like measuring data downtime, measuring data corruption, looking into errors that occur, that happen in production, and be able to respond as fast as possible if something produces disruption to your user. In terms of performance, expectations today are to have software that is responding as fast as possible and offers a fluid experience. So I really like this quote, slow is the new down. So it's not enough just to be online. You also have to serve the customer very fast, because the poor experience will make them leave or go to another product that performs better. Also, if we look at through the team's lens, we can see performance as the ability of the organization to continuously deliver software. So instead of looking at long life cycles, maybe of months, of years, users are having this expectation to get features as soon as possible and as often as possible. And this leads into teams being forced to optimize the speed of deployments, to improve infrastructure, to shift code more often, and this leads them to the need of automation, creating pipelines and monitoring all the performance involved with how the software responds. In terms of scalability, we need to be able to configure systems that are responsive to the growing number of users. So we no longer have to think in fixed terms, like having a fixed resources, but having an infrastructure and a system that is able to scale and expand during high demands, and then to scale down when the demand falls. So this might also translate into the team's ability to scale, because organizations are in an organization that are natively digital or become digital, are onboarding new people with skills that are required to maintain the software that they're building. So we need to bring in the tools that allow your organization to grow and to adapt its processes as the team is growing in numbers. Last but not least, we want software that can be very easily maintained. Maybe it's very easy for everybody to understand that when you buy a car, there's some maintenance involved, but it's at very specific moments of time when you reach a certain mileage or an amount of time has passed. But maintenance in software development is a process that happens constantly from the first day you've written the first piece of code. So you have to assure the team has the ability to read, modify, extend the code, rewrite it, and then ship it and make sure that everything works as desired. Also, in terms of maintainability, we need to have the abilities to make the infrastructure more explicit and to describe it so that people that get onboarded know how to produce these changes efficiently and effectively. So putting all these principles together in a team, it's not an easy task. So you have at the core the philosophical part of different departments collaborating together. You have the outcome part of getting faster in the market, and you have all these characteristics that you have to strive to achieve in a team. So let's see what kind of usual problems a team faces when dealing with DevOps, and see what kind of solution we have on Bunnyshell. So let's imagine the story of an agile team. And this is the story I see a lot while working with teams. So for example, we have Alice here, that is a backend developer. Then we have Bob, that is a front-end developer. And they work together on their local machine. And let's try to imagine, even if it's in a linear way, their process for deploying software. So Alice and Bob, they work on the local machine. They have all the code version in Git. So they each work on their specific branch with the feature in mind. But shifting the code towards your customers, it's actually an entire process. So maybe we have Chris here. He is a QA engineer, and his expectation is to actually test both the components integrated. And after long struggles, they managed to have a testing environment. We also have Diana. She's the product owner of the team. She's very eager to ship the code to its customers. She knows their pain points, and she usually does demos on the staging environment before putting everything in production to actually see the effect of their works. And on this long cycle, our fictive team, probably you feel represented in this kind of story. A lot of challenges occur. So we also have Eddie here as a Scrum Master. I just facilitated the latest retrospective and see the problems that this team is facing. So what they told me is that they really want to have some automatic deployment. So they are very tired of doing this configuration that they made on the local machine and then moving the configuration and the actual code through these local environments and testing environments, staging environments, and production environments. Because software is hard to understand sometimes and is very hard to debug, having all these environments means they have a lot of logs to deal with, and they want an easy way to understand what is happening and how to debug the software on this environment. So another thing they added at the retrospective is they want a way to do a log creation for this server. Another problem that they have is they are not able to monitor the software. So all the instances they have here for testing, staging require resources, and they don't know where their resources go. So resource Resource monitoring, it's another common challenge that they are facing. And we're closing to the production. Here, the number of customers grows, and sometimes they have a high demand, sometimes they have a low demand of customers. So they want to incorporate this dynamic with automatic scaling. And obviously this involves configuring a very high-end load balancer to balance the traffic between servers. They don't have very much experience with this, but they figure out this is a solution for them. Okay, hopefully you already started to empathize with these fellows in my Agile story, and you feel the pains in your team too. So how can you go about it, and how can you offer this kind of infrastructure for a team like this? One way would be to start building it yourself, or another way would be to use a tool like Bunnyshell and start creating your infrastructure there. So moving forward, let's see what our fictive team might find in Bunnyshell. So Bunnyshell is a self-service infrastructure automation platform. It's a cloud agnostic platform to build, deploy, manage, scale, and optimize your application. The solution comes in several verticals. So you have the part of managing your infrastructure, where you can do automatic deployments, provision your resource, configure load balancers, and set up all the self-healing services, like monitor the resources that you have and restart them if any problem might occur. The other layer is the application layer, where you have the most powerful and common content management system, access to frameworks that you can deploy with one click, and configure everything around the space of your application, like cron management, doing all the domain management and association of the subdomains, CDNs, and dealing with certificates for those applications in order to make them secure. And the third vertical is the one around DevOps tools, where you have custom deployment recipes, log aggregation, monitoring for your production and development infrastructures, alerts, monitoring of the uptime, and even backup and automations. How they do it? You start by connecting to your cloud providers. So there are multiple cloud tools that you can connect. Then orchestrate the entire infrastructure, configure your application deployment pipeline, and then use the DevOps tool to optimize and get more performance from the infrastructure that you have created. But for this part, I think seeing is believing. So let's see how actually the tool looks like, and move to my favorite part, that is the demo. Okay, first of all, the part you'll need to do in Bunnyshell is connecting your cloud provider. So we work in this paradigm of having a cloud agnostic platform that will allow you to create your infrastructure, whatever cloud resources you need. So you have DigitalOcean, Amazon Web Services, Azure, Vultr, Linode, and Upload as providers that are already integrated there, and many more are yet to come. Having your cloud providers connected, Bunnyshell allows you to organize resources in two types. So one is virtual machines. And for example, I have two here already configured, but provisioning resources is a matter of selecting your preference for the web server, the desired programming language that are necessary on your server, selecting the persistence layer. For example, I will go for MySQL now, and Redis for cache. And let's say we also have a document-based database in MongoDB. Then choose the provider. So for example, I have DigitalOcean and AWS connected here. I will go with the DigitalOcean. Select the location where you want to deploy your resources, the operating system, and the size of the machine according to your resources. So in the background, this will create all the install process for you, so you don't have to do anything, and what you will get is a virtual machine that is pre-configured with the resources that you provisioned and with the language that were selected. Moving forward, the application layer allows you to deploy one-click application on this virtual machine. So one setup that you might find yourself in is having a virtual machine and deploying multiple applications on that virtual machine. So you can start with a virtual machine that's already provisioned. And then depending on the configuration of that machine, you will get recipes for installing CMS, latest frameworks like Symfony, K, CodeIgniter, and Laravel, or even install tools that might help you in your development process. So for example, install phpMyAdmin or Adminer to deal with the database. You also have the option to start with an empty shell application that will allow you to deploy your own custom application. But let's start with the Laravel app. Deployment, it's a matter of minutes. So in the background, this process is creating a dedicated user for this application to start in, a user that allows this app to run contained from other applications. So on a virtual machine, you might have more than one application that is configured, and it's secured and is contained from the rest of the infrastructure. While this deployment is in progress, I want to highlight another feature. So the first one was the virtual machine part, where you had a standalone application, a standalone server with multiple application deployed. Another instance that you might find yourself with is actually configuring a web server. So what does this mean is that you can have a load balancer in front of your infrastructure and then have multiple instances of the machine. So if it's easier to imagine, let's say the configuration will end up like this. You have your customer that connects to your domain. Then in front of the infrastructure is a load balancer, and you can configure several instances with your application. So what the load balancer does is taking the traffic and with specific rules is redirecting that traffic to either of the instances. Of course, you will have to also provision a different machine for persistence. So if you have an application that would require a database, that machine should be a standalone machine so that each instance will be able to connect to that persistence layer and share the same database and share the same resources. Even in an even complex situation, you also have a scalable database system where you also have a master database and multiple databases that are connected there. So this is what is called a horizontal scale approach, where you try to distribute your traffic towards multiple machines. And configuring this in Bunnyshell is then a matter of increasing the number of instances, and everything will get configured and automatically deployed on the new instance. Turning back to our application, you see that it has been provisioned now. By default, you have an FQDN assigned to your machine. So what we're getting here, it's the default Laravel installation. And for each application, as I mentioned, everything is contained under its own user. And automatically the database credentials were created. So in this section, you can do the management of your domains. So for example, if I want to change it into demo.developer.com, you can change the domain for that machine. And normally now you would have to go into your DNS provider to also make the change to that machine. So what you can do, it's also have your DNS providers integrated. For example, I added my Cloudflare integration into Bunnyshell, and you only have to manage the changes in only one place. So in this case, it's a CNAME. You have the demo name, and you can either proxy it and also get the performance improvements from Cloudflare, or leave it to go directly to that machine. Okay, so now we're in the same demo setup with the default Laravel installation. Obviously, having only the default page won't be very useful because you want to create a pipeline for your team to work with. So the last part I want to demonstrate is the deployment part. And in this part, having your Git repository connected, you are able to select one of the repositories in your organization. For example, I have one already here. Then configure the deploy path. In this case is the path where the app is launched, and have the user that is deploying there. With this deployment created, you can then associate the servers where you want to make that deployment. You are able to configure deploy steps. So for example, for Laravel, we need to install the composer dependency. So you can see here that there are a bunch of recipes that are already added in there, and you can simply search for composer install. And add it as an action in your deployment process. Also, you are able to do secrets management from this side. And there are different templates. You need to configure a baseline for that file, and the name of the file that gets exported. And the most common formats are already predefined for you. So for Laravel, it would be bash, and then any specific secrets or configuration can be configured from here. So you will have to specify them by name. For example, the DB host, it's localhost. And having this deployment configured, you can then add it to the server that you just configured, and it will deploy from your Git account a specific branch. And in the background, Bunnyshell will do all the steps for you, like git clone, and then do the deployment steps, apply the secrets, and start your application. Okay, getting back to our team, it seems like it's a really helpful system then for them, because it covers their problem with automatic deployments, log aggregation, monitoring resources, and even provides recipes for complex infrastructures that involve a load balancer and automatic scaling. I would just like to end up with also a case study that I did for a local NGO in Bucharest that is helping young people to get jobs. And so in this period of pandemic, they had to shift their digital to a digital environment, and they were not able to do trainings, real life trainings anymore. So their pressure on being active and being a digital presence was very big. And just to have an overview of what their setup looks like, we have a virtual machine where some static websites developed in WordPress are deployed, a staging and a production environment for a platform for searching jobs, and another server for a platform where they provide tests for people to assess their abilities, deployed on a separate instance. In terms of applications, on these servers, we have deployed multiple applications. So for example, the presentation websites in WordPress are deployed on machines. The Laravel applications on the staging and production, tools for accessing the database were already configured and provisioned through Bunnyshell. And we also use the deployment parts for both staging and production. You can revert back to a previous version. So you, for an organization that lacked all these resources to configure a very performant infrastructure, having this with Bunnyshell was a great thing to do, and it enabled us to work even better with the resources that we have. Having this in closing, we still have some time for question and answers. So if we already have some questions, I'll deal with them. You can either post them in the chat or ask them directly here. So we have one from Bogdan. Thank you, Bogdan. Nice to meet you here. I saw a mention for on-premise. How is this handled? Sorry. Okay. On-premise. So I imagine that you have your specific servers and you would like to have the automation in place. So how Bunnyshell works is like an agent that stays on your server. And even if you have the cloud providers connected, you can also deploy it to the servers that you already have. So any Linux server that is able to run the agent, I think Ubuntu and CentOS, can also be onboarded in this infrastructure management tool. So it's a matter of configuring the agent, and the instructions are both in the documentation of Bunnyshell and in the interface, and then you can use the tools that are already there with your own servers.
So if I understand correctly, this only means that you cannot provision virtual machines. You have to have them already configured, already present, enroll them using an agent, and then you can manipulate them using the Cloud Shell.
Exactly.
Okay.
Exactly. Cool. Because on the cloud level, everything is done through the APIs of those providers, and you can also do the provisioning. But correct, if you have your own infrastructure, you have to somehow deploy them and then connect the agent to that machine.
Got it. Thanks. Your comment leads a bit to another question that I had. How is the cloud provider being manipulated? You mentioned APIs. I saw 3 major cloud providers over there. Is there any tool between Bunnyshell and the actual APIs for the specific cloud provider, like, I don't know, Terraform or something like that? Is any specific tool being used, or does Bunnyshell have some implementations that interact with different APIs for different cloud providers?
I have to admit it's a pretty low-level question for me, but I know it's something proprietary.
Okay.
So
if it's proprietary, then yeah, I got it.
maybe if someone from Bunnyshell is here, but could add in. But I'm not aware of using something open source like Terraform or things like that.
Thanks.
Thanks for the question as well. Okay, I will still wait for a few more questions.
Okay, if we don't have any volunteers, I can have a few other questions.
Sure.
So you showed us a bit how you install an existing application like Laravel.
Mhm.
Can you configure in any way? What are the steps required to actually configure those things? I mean, do you have recipes? Do you have anything that you could build by yourself? I don't know,
Mhm.
maybe you have a custom application that you just developed and you want to deploy it, and you have a custom scenario to make that happen.
Mhm. Mhm. So for example, having your first step would be to have your Git account connected. So you can connect GitHub, GitLab, or Bitbucket, or if you have an in-house repository, you can specify and connect a specific repository with a private key if it's private. So having this done, then when you configure deployment, you need to specify the branch where you're deploying. And let's assume that there are several steps that you need to make, like install dependencies, then run npm install for JavaScript dependencies, and then run an extra script that is very specific for your application. The way to do that is through the deploy steps. There are two stages. One is the pre-symlink and one is the post-symlink. So what is that? That means that you clone the application, you can run some instructions before symlinking them, and symlinking means that that specific directory where the new version of your application was cloned will be symlinked to the original application that is served by the web server. And you have to decide where this needs to go. So if it's something to run before or after the symlinking, but then you can add them like steps here. So the recipes, some of them are pre-configured. So for example, restarting some server or installing Docker or cleaning up. So you have a lot of templates, but I think you also have like custom. You can have a new script. I didn't do that too much. So usually is using the recipes. So you can even have a bash script that you can write it here and it will get run. And this will depend also on your configuration. You can run it only on specific servers if you have a load balanced environment or only on one of your servers. So you can get into customization pretty fast with your application. In the end, in the deployment logs, because you want to configure the runs, but you also want to make sure that the runs are happening. So you can see all the steps and see the actual logs that it becomes very rarely to have the need to go to SSH that machine and to do manual configuration for those machines.
Looks good. Thanks.
Thanks. Okay, do we have any more questions? Thanks, Bogdan, for this one. Okay, if not, I will be closing with some conclusion and some thank you notes on having you all here. So I'm really grateful that we had the chance to have this talk and to also connect the fundamentals of the DevOps, but with also some real hands-on demonstration of what you can do to help your team achieve those principles and practices. It was really nice for me to have you all here, and if you would like to keep in touch, we can connect either on LinkedIn. Also, I encourage you to start a free trial with Bunnyshell. You can also get free credits for DigitalOcean to play with, and other cloud providers that they have partnership with. And having a feel of the application and try to create your own infrastructure it's a very fun thing to do. And then take the knowledge that you gain here towards the team and make this community grow. Also, feel free to contact them. For me, being more focused on the development and methodology, I don't always have all the details there, but they are very responsive and willing to help. And the chat always helped me to understand new things and how to improve my infrastructure. And I have to say that helping both the NGO to build their digital platform and using it as a tool really made me feel a better developer and gaining a better understanding of these principles and practice. So thank you all for joining, and for definitely we will meet again in other formats and other topics to discuss and debate.
Goodbye, have a nice day.
Thank you.
Thank you, have a nice day.
Goodbye, have a nice day.